All right, for this video, we're going to be going over the domain and range practice that we attempted to start during class today, and depending on the class you were in, whether you're in Coach Walton's class or if you're in Mrs. Doherty's class, we may have covered different things. So what we're going to do is go over the whole thing and just kind of skip around to the places that you might need or not need. So we're starting on this side where it says imagine the possibilities. And we're going to be finding the domain and range for each situation. So as I zoom in, hopefully you understand that we're not able to increase the quality of this video, so I will try my best to. I realize that it's a little bit blurry. But on problem number 1, we're looking at a discrete graph, meaning that each of the individual points that I'm highlighting here. This point was, I need to cross this out. This was not a point on the graph. I think I just accidentally wrote that there, but I can't erase it. So each of those highlighted points are the points of this discrete graph. So I could pull out each of the individual points and then write them in the domain and range. So that's what I'm going to do. I'm going to start at the furthest left. I'm going to look at this point right here, and then I'm going to go to the right. So my least value here is, so if I were to find the coordinate pair for this dot here, I would notice that at the bottom we have each of these marks that are going by 0.5. And then on the x-axis we're going by 0.25. So we need to making sure that that is clear. So this first point, the point here, we're going at 1.5 for our x value, 1.5, and then my y value is all the way up here also at 1.5. Okay, we're going to do that for each of the points. So moving up, we have at a 2 for my x, and then a 3 for my y. All right, moving up, we have going down, we have a 4 for my x value, and right across, we have a 4.25 for my y. And then the last 2 points coming down here, we have all the way over to 3.5, so it was right there, 3.5 for my x, and 0.25 for my y. And the last point here, we have all the way over at 9 for my x and 0.5 for my y. So we have each of those points labeled individually. So what we need to do is take the points and transfer them for domain and range. So we have x, y, x, y, x, y, and x, y, one more, x, y. So we know that our domain is our x values and our range is our y values. So now that we've done the hard work, we're not, it's not very hard anymore. So we just need to list our domain values from least to greatest. So we see over here, our domain values is our x values, our least x value to our greatest x value. So our least right here is going to be our x, that's 1.5. And then after that, we have 2, and then we have 3.5, and then we have 4, and we have 9. And make sure I got them all. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those are our 5 domains for this graph. So then our ranges are the y values from least to greatest. Our least is 0.25, so that's the least value here. We have 0.25, and then we're going up to 0.5, and then up to 1.5, and then 3, and then our highest y value we see up here is at 4.25. So these values here are the domain and range values for this graph. So we need to understand that for discrete graphs, we are able to physically list all of the domain and range values. This is not a continuous graph because we can physically see each of the individual y and x values, unlike when we have a continuous graph because of all of the extra decimals. So there's question 1. Okay, question 2. So this one, they already found the coordinate points for us. So what we need to recognize here, xy, 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 and xy. So we know that our domain is our x values and our range is our y values, and we want to list them from least to greatest. So what I can really do, we know that this here, if this is -3, -2, -1, and 4, -1, 7, 0, 3, 1, 5, 2, and 5. So really what I can do is I can look here and I can take this and I see it's my x value and I can just take and put it down here. And my next x value is -1. I can take it and put it down here. And then I see another -1 here, but we don't have to repeat it if we've already written it one time. It's just repetitive. So then from there, I don't need to write that x value. I'm going to take this 0 down. And then I'm going to take this 1 down. And the last one is the 2. So that completes our list here. And I just separate them with commas. So it's just taking all of your x values and showing how far your graph extends. And so, let me see if I can now. I'm going to go ahead and erase this one. Erase this little one because we didn't need it because it was a repeat. And then what I can do is now, because I have just my y values left, is I can take all of these values here. Oh, I'm going to have to take a couple y's with me. So I can see here that now we have our list of y values, except my only problem is, maybe that wasn't very good. My only problem is here is that now, let me move these up here. We notice that these are not in numerical order. So we have all of our y values, but I'm just going to take them and write them in numerical order. So we have -2, and then 3, 4, and then look, we have 2, 5, so we only need to list one of them, and then 7. So that concludes our range values. All right, for number 3, says Winnie is driving at a constant rate. It takes 4 hours to drive 232 miles from her home in Dallas to her parents' house in Houston, Texas. She creates a graph for distance versus time for the trip using the equation D equals 58t. So I'm going to write that a little bit more. So I'm going to say distance for D. Distance equals 58 times time, or multiplied by time. So if we were to take the information that they gave us in the equation, we see if our time here is 4 hours, and then picking another color, our distance is 232 miles. What we can do is see that in 232 miles, we did 58, and then that was just by multiplying it by 4. So, and that's really something we don't necessarily need to know, but we could figure out how far she traveled in 3 hours, in 2 hours, in 1 hour. But because the moment she hopped in the car, so if this is her time, and this is her distance, the moment that she hops in her car, so at 0, 0, when she's traveled 0 time and traveled 0 miles, then the moment she starts driving with increased time comes in increased distance. So this is going to end up being a continuous graph. So we need to make, rather than a discrete statement about domain, we need to make a continuous statement. So we know that in 4 hours, she traveled 232 miles. So now we can make that statement using our full statement here. So we know that our least x value is 0 because you have to start at 0. So 0 hours is less than or equal to x, which is less than or equal to our highest x value, which is 4. I almost waited for someone to respond to that. Okay, so then we now are looking at our range. So going from our least y value to our greatest y value. So we see it extends from 0 to 232. Since we're talking about y, our range, so we know that y is greater than or equal to 0 and less than or equal to 232. So that concludes our statement there. All right, and number 4 we have here, we have our domain and range. So again, this is continuous. So that means we're making a statement, we're making a statement that a number is less than or equal to x, and then is less than some other number, or y, depending on the circumstance. So in this graph, we see here first, if we're looking at the domain, we're looking from 0, because our least x value, so it touches 0, and then it keeps going, and then it stops right here at 9.5. So we know that our least x value is 0, so we're going to start there. And we know that x is greater than or equal to 0, but we know that our x also is less than or equal to 9.5, because that's the furthest our graph goes. So from 0 to 9.5, that is the extent of our domain. But then with our range, now we need to go from bottom to top. So our lowest, as I follow my graph up, and up, and up, if I keep going up and up and up and up and up, then I stop here at the top. So I see that my graph goes all the way up to this point right here, which is 22.5. So our range goes from 0 to 22.5. And now since we're talking about range, we're talking about our y values. So our y value is greater than or equal to 0, but less than or equal to 22.5. All right, so there's page 1. And I have those there. Okay, so page 5 through 8. So now we have here, I'm going to zoom in on number 5. So we have, we're looking at domain and range again. So again, we're looking from, so if I were to, I'm looking for my least x and my greatest x. So I have my statement. So I have here at -6, -4, -2, and then 0 and 2. So we have our graph extending on the x-axis from -6 to +2, and our x value is greater than or equal to -6, but less than or equal to +2. Because it only goes from here, from this point that I'm shading right now, to this point that I'm now shading here. So that's the extent of our domain. But then our range, now we need to talk about how low, what's the lowest point on my graph, which we see here is -4. And our highest point is now up here at +1. And so our y values are falling greater than or equal to -4, but less than or equal to +1. Okay. All right, number 6, a senior citizen group is making a fruit basket and plans to sell them as a fundraiser. They are able to make 10 fruit baskets and want to sell them for $35 each. So they're able to make 10. So 10 is the max, but they could also have anything from 0 to 10. So that helps us know that. So first we need to figure out a little equation, kind of like we did before. So 0 is, so if I said that the amount of money raised, so money, maybe I'll use a money sign, is equal to the $35 times the number of bee baskets. So if I look at that, think of that as a graph, I know that I can actually look at y equals 35x. So now I can take my baskets, so we know they can make anywhere from 0 to 10. So our domain values are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I realize that's a lot. And so what we're going to need to do is take our domain values, our x values, to figure out what our y values are. So we're going to take each of our values here, and we're going to substitute them in for x. So 35 times 0 would give us 0 for our first range value. And then when we plug in 35 times 1, we would get 35. And then keep going, y equals 35 times 2. So again, I'm just substituting these x values in. Oh, I skipped one. These x values in to figure out what our range value or our y value is. And 70. And then I'm not going to do the rest of these, so this would be just continuing to substitute in your x values, which you can do. All right. Number 7. So again, but now this time they gave us an equation, but they're saying we want to find the domain and range for all of the prime numbers less than 15. So prime numbers are any numbers that can only be divided by 1 and themselves. So our list is going to be 2, 3, 5, 7, 11, and 13. Pretty sure I got them all. So these here are going to be our x values. So these end up being our domain. I'm going to see if I can just take these, move them down. Perfect. And then what we're going to do is just what we did before, is now we're going to look at each of our x values and seeing what happens to our y when we substitute in these specific x's. So we have -4 times 2, which is -8, and then -10, so we get y equals -18. So that is our first range value when given x is 2. So now we would do -4 times 3 minus 10. So now we get y equals -12 minus 10, which is -22. So again, I'm not going to do all of these, and you would just continue to substitute in those x values to finish your domain. Finish your range. And then this one here is pretty easy. So this one here, since we know our input is our x values and our output is our y values, and we know domain is x and range is y, what we can do with each of these numbers, -3, -1, 1, 3, and 5, we can say each of these inputs goes in our domain category. I wish I could turn them. And then each of our outputs, so each of these outputs is going to go in our range list. Okay, and there's no repeats, and they're in sequential order, so you can just keep them that way. All right, so there is that, and then there's a few more questions on the back. Okay. So Kiara was driving in her neighborhood and approached a stop sign. When she applied the brakes, it took 4.5 seconds to come to a complete stop for a speed of 20 miles per hour. If Kiara creates a graph of her speed versus time as she applies the brakes, which of the following would describe her domain for her graph? So initially, when we first look at this equation, something we can already examine here about these answer choices is that these both have y's, so these are giving range answers, and so we automatically know that those cannot be right, because domain is x, so we know that our x statement is going to be like this, and we just need to figure out, and even from our answer choices, we see that 0 is going to be our least x value, because obviously she started, and then she needs to stop. So we're looking for speed versus time. So we know that she starts at 0, so we know 0 is going to be the least value. And then because of her speed versus time, we know that it took her how many seconds? It took her 4.5 seconds. So time is going to be here on the x, and speed is going to be here on the y. So we know that at 4.5 seconds, she came to a complete stop, depending on her speed. I guess it probably would be going, her speed would be going down. Like this. So her speed would be coming down to a stop. So that leaves us with our range, or our domain, being from 0 to 4.5, because that's when she completely stopped. All right, so on this one, we're looking for the range. So just good test taking strategy. Which of the answers can we eliminate before even looking? We see that these are both asking for domain, so we can erase those. And then when we are looking for range, we know that we're going to go from bottom to top, bottom to top, and then see what happens. So we see our lowest point is 0, and our greatest point here at the top is 95. And so now we're going to see which answer choice indicates that, and that's D. 0 is less than or equal to y is less than or equal to 95. Okay. All right, 3 and 4. So this one here is asking for range. So again, we're doing bottom, least to greatest. So our least y value is here at just above 100. So it looks like it's not right on the bat. So then we have something 100, and then our greatest value, is right here, just right above 400. So now we need to go, something needs to go up to 400. It needs to be a little bit higher than these numbers. So when we look at our answer choices, we know that A, B, and then C looks like it could be right, but we notice these here, and these are not indicating X value or Y values. These are this includes X and Y. So we just know that would be our answer, because it's from negative 105 to 405. And our last question here is asking for the domain. So now we're looking for our x values. So good test taking strategy. We can eliminate these because they have your y's. So now we're looking, how far does our graph extend along the x-axis? So we start here, and if I'm moving my finger, my laser across, I know it goes past 1, 2, 3, 4, 5, 6, 7, 8, 9, and then right here it stops at 10 seconds. So we know that it's going to be between 0 and 10 because we're looking at x, and that is our answer here we see at answer choice A. So hopefully that helps a little bit, and good luck.